So let's do some completely unscientific market research. Raise your hand if you've heard of and understand what the Applied Networking Research Prize is. Okay, it's good. A few hands and lots of no hands, so this isn't completely redundant. Slide, please. Do I have a clicker, or do I need to? Oh. So, if you, yeah, it's probably better if I have the clicker. Yeah. So, okay. So one of the things I try and do at ISOC is come up with ways of trying to bridge the gap or the gulf or the divide between the research community and the IETF, IRTF communities. I'm sure you're well aware that the IETF has its origins in the research community, but over the years, and the IETF is increasingly long in the tooth now. The research community is still there to some extent, but perhaps not as strongly represented as it used to be, and so that's of concern to us at the Internet Society. And the Applied Networking Research Prize is one of the initiatives that we have kicked off to try and address that to some extent. I want to say very clearly at the outset that this is done with the in very close collaboration with the Internet Research Task Force. And so Lars Eggert, who I expect some of you know, chairs the IRTF and works very closely with me on putting the Applied Networking Research Prize together. This gulf between research and the IETF standardization world, it was interesting to me I went to SIGCOM in Helsinki last summer, and Nick McEwen gave a keynote there where he talked about the lack of industrial representation at SIGCOM. And so it's kind of like, that was really interesting to me to hear this. It was almost the inverse of what we're trying to do with the IETF and the ANRP. The problem is perceived from sort of both ends of the telescope. So what is it? Well, we're trying to recognize recent results in applied networking research. And as I say, the goal is to try to foster this transition of research results into real-world benefits for the internet. So we do that by bringing the prize winners to the IETF and giving them an opportunity to talk. And the hope is that they'll there meet folks who are also interested in working on the same kind of problems, or they'll meet folks who are already working on similar areas. They'll meet people who are able to take their ideas and implement them and get them deployed on the internet. It's awarded 3 times per year in conjunction with the 3 annual IETF meetings. And I'll talk a bit more about what it is and how it gets awarded on the following slides. So what is it? Well, it's an invited talk primarily. The main thing is that you get to present your paper to the IRTF open meeting, which is, the IRTF is a separate organization to the IETF, but that meeting takes place during the IETF meeting week. There's a cash prize, there's a travel grant so you can actually physically attend the IETF meeting, and recognition at the IETF plenary and invitation to social activities. Lars is very good at picking excellent wine, so that's near the bottom of the list, but perhaps it should be nearer the top. And for prize winners who demonstrate, that their work has gained some traction in the IETF, either because they have internet drafts that are being discussed on the mailing lists, or because they've been invited to present at working group meetings and so on, then there is potential for additional travel grants to future IETF meetings as well, because as I said at the outset, this is about trying to foster that collaboration. So it's not, it's not a sort of one hit, oh, congratulations, well done, goodbye. It's kind of like, we hope that you can take advantage of this award to really develop some work in the IETF, and so we're looking to support that if we can, and if you can bring evidence to us that that's actually happening. So to apply, you need to nominate a peer-reviewed paper. So we're not looking to do the scientific review. It has to be a paper that's been submitted and accepted to a recent conference or workshop. You can self-nominate, or you can nominate somebody else's paper. So if you've written a paper that you think is excellent and you'd like to win this prize, by all means nominate it. if you, in your day-to-day business, read a paper that you think is excellent and worthy of this award, please do nominate it. The nominee has to be one of the main authors, not necessarily the main author, but one of the main authors of the paper. And the call for nominations for prizes for next year will be opening, well, real soon now, certainly around the Berlin IETF, which is this summer in July. The selection committee is this bunch of folks here. As I say, we're not really trying to do a detailed scientific review. That's why we ask for papers that have already been accepted. We assume that's been done. We're much more about evaluating the quality of the submissions against the criteria for this award. So, does it seem like work that would be of interest to the IETF community? Does it seem like work that's likely to gain some traction within the IETF community? Is this somebody, the nominee, that we have not seen around the IETF before, you know, a newcomer, in other words? Those kind of things are what the selection committee is looking for in making their decision. Some slides of the previous winners. We started a couple of years ago, I guess, IETF 81. Where we had 2 prize winners, and the other thing here to note is you know the variety of topics that we've been awarding these prizes for. So you know it's quite diverse. So the first awards went for routing related topics. The second set of awards were more in the sort of transport space. Michio's work on the extensibility of TCP, Nassif for his work on TCP receivers. We didn't have any awards at the IETF 83 because we decided at that time we were you know having a call for nominations and reviewing submissions every you know 3 times a year at each IETF meeting, and we decided that was just too much work for the selection committee. So in the interest of making our lives easier, we're now doing it on an annual basis, but that meant there were no awards at IETF 83. IETF 84, Alberto was awarded for a very interesting paper where he'd done some analysis on the kind of disruptions that we were seeing around the Arab Spring and measurements that he was able to make using some of Qaida's infrastructure and other internet measurement infrastructure. IETF 85 had some awards for also a sort of measurement related stuff, broadband measurement for Srikanth. Payman, a much more theoretical paper, but you know, again, so there's quite a diverse range of stuff. Most recently, Gonca Gerson from Boston University was awarded for her work on defining a metric to analyze BGP tables. So you know, we're open to anything really, but it has to, you know, as I say, it has to sort of seem to the selection committee like it might gain some traction in the IETF if it's presented there. You may have noticed I've been sort of going around distributing these leaflets on the coffee tables. If you want to win a Raspberry Pi, you can do so by entering our simple survey online, which will close. I guess I'll draw them tomorrow around noon or around the lunch break tomorrow. So if you don't have a Raspberry Pi and you would like one, your odds are pretty good at the moment, maybe 1 in 2. So, you know, even if you don't want one, but you just want to reduce the chances of anybody else winning them, go ahead. The questions are not very difficult, especially if you've sat through this talk. So go ahead and enter that if you fancy winning. That's how to stay in touch with ANRP, although that is a general IRTF announcement list, so there will be other occasional traffic on there relating to the Internet Research Task Force. But if you want to know, for example, when the call for nominations for the 2014 awards opens, it'll get posted there first, and announcements relating to the prize winners as well, of course.
According to this, the prize winners get a /8 of IPv4 address space.
That's one of the options, Tim. Yeah. Why don't you select that one and then into the prize draw, see how that works out for you. That's about us. That's mostly there for people who want to read it. Yeah, and then finally, just a general point. I think you know, as I said right at the beginning, one of the things I try and do for ISOC is think about bridging this gap between the research community and the IETF. And I'm very open to hearing any ideas that anybody in the Terrainer community, for example, has about collaboration in future on other topics. We're in ISOC constantly running up against questions of deployability of technology and measuring different aspects of the internet to draw conclusions about where to focus our efforts or where to encourage policymakers to focus their efforts, for example. And so, it strikes me that the research networking environment may be one in which it's possible to run experiments or derive results that because of the more commercial nature of the big I internet, it's more difficult to do that there. Either because you can't get the traffic data from commercial ISPs, or because the time to get new technology deployed on commercial networks is so long that you can't get things done. Whereas perhaps in a research networking environment, things are more flexible. So I'm very welcome to hear any suggestions you might have for things that we could do to work together to answer some of these questions. And my contact details are on the next slide. And that's all I had. So if you have any questions about that, I'd be happy to answer them. Otherwise, thank you very much.
Yeah, thanks, Matt. Other questions? Questions about raising chances to win the prize? Okay. I guess then we quickly should proceed to our next speaker, who is from Ping Identity. John is ever since working in identity management, is that correct?
I started off in identity management doing PKI when I was a small child.
Okay,
Yeah,
so I guess
grew up doing LDAP.
that is a good introduction to your
I
talk.
don't do that anymore, I'm better. Yeah, so now I work for a software vendor, so I should give you the disclaimer that everything I tell you is inherently untrustable. So be very skeptical. So I'm going to talk a bit about some of the new standards that are coming out. Start off with something that people have been asking me a lot about, OpenID Connect. So that's a OpenID Foundation standard. We have our own standards process at the OpenID Foundation, bit different IPR. The companies that participate in developing the standards have to agree to a non-assert on all IPR rights over the eventual standard. So in some ways it's arguably a bit tighter than IETF, sort of a mutual assured destruction thing amongst the large players. So you can think of OpenID Connect as an SSO profile for OAuth. A lot of people started doing, with OAuth 1, they started trying to do single sign-on, and they were doing it really badly and insecurely. And when OAuth 2 came out, Facebook attempted to do single sign-on with OAuth 2 and managed to, in several ways, have zero security. So we decided, maybe we should actually do a proper profile of how to do identity on top of OAuth so that people wouldn't keep shooting themselves in the foot. We're now at a second implementer's draft vote, so we're in the 45-day review cycle before, for OpenID standards, the entire membership of the OpenID Foundation gets to vote up or down on different drafts. So we've gone through 5 rounds of interops. So with each set of draft documents, we essentially run an interop so that we can learn what does work, what doesn't work, and change it, feedback from the developers and deployers get fed back into the specs. So we've now been through 5 cycles. We're just starting the 5th cycle, which will be based on the voted, on the proposed implementer's draft. The final vote after the implementer's draft is approved, assuming it is, will happen a bit later this fall. So while the standards process is going on, we already have a large number of people who have OpenID Connect endpoints, Google, eBay, AOL, Orange, IBM, Ping, Layer 7, MITRE, who you may or may not know is a US military contractor, Nomura Research Institute, GLUE, who you probably know from the Shibboleth community, and Giant, who Roland Hedberg, who isn't in the room, has actually developed a test harness for as the reference implementation of OpenID Connect, which Giant has stood up. So there's a lot of development activity around OpenID Connect. The other standard that OpenID Foundation is working on is something called Account Chooser, which is, if you're familiar with SAML single sign-on, there's something called the cross-domain cookie, which has horrible security and privacy sort of issues. So Account Chooser is, you could think of as a really smart cross-domain cookie using the latest HTML5 JavaScript local storage in the browser. So essentially it builds an application in the browser dynamically that keeps all of your account information in HTML5 local storage and presents you with a UI when the relying party triggers it. So the Account Chooser site, which is run by the OpenID Foundation, it's actually hosted by Symantec on some of their secure infrastructure that's replicated around the world. So it's hosted as securely as we can. Having people modify the JavaScript code which gets loaded into people's browsers would be, of course, a serious security concern. So we've put a lot of effort into securely hosting it. The code is available via GET. You can, anybody who's curious about whether or not we're doing something nefarious can just look at the live code and audit it as they will. All of the information, so the main website, if you want to use it, by the way, in my online version of the presentation, all of the links are live. So any of the things that are highlighted in here, you can just go to the online presentation, click on, and wind up at the right place. So the main Account Chooser site is live. You'll have seen it if you go to Google Properties. Google has a captive version of Account Chooser, and a few other people are running their own versions of Account Chooser. Now, Account Chooser isn't actually specific to OpenID Connect. It can be used for any protocol. We have people that are experimenting. Ping is experimenting with using it for SAML as well. It's protocol independent. It's a wave. So the central site is live. If you run your own local version, of course, you don't get the advantage of identities that are pre-populated. You only get the advantage of the ones that are for your set. And there's accountchooser.net, which has all of the information, specifications and stuff linked from it. And you can see this is an example. This is my Account Chooser page. When I went to log into a site, it triggered the JavaScript. I have the various accounts I've set up in it. You can have, so you have an identifier at an issuer or entity ID. So you may have the same username, but we actually have various graphics to say, well, you're jbradley@microsoft.com, but with Google as your IDP, because you can have a Microsoft email address at Google and all of that now. So where an email address isn't necessarily an identifier that you use, which is an email address for logging into a site, isn't necessarily tied to the company that issued the email address, which makes life a bit more complicated than people tend to think on the internet. There's a section of Account Chooser over on the right, which is actually controlled by the relying party. So we've been working with, some of you may know Ben Laurie from Google. His project Carhar, which is a sanitization package, which allows us to suck in dynamic HTML from the relying parties and be able to safely display it in a controlled environment. So essentially it's a HTML sandbox in HTML. So that's actually an interesting project if you're into that sort of thing. So we're using Google's Carhar stuff to be able to present information from the relying party over on the right-hand side. That makes the relying parties a lot more comfortable in that their branding doesn't completely disappear when you're redirected someplace. That really freaks out a lot of relying parties. So there's a fair amount of Account Chooser work going on. One of the things that OpenID Connect has a dependency on is, of course, OAuth, and people keep asking, when is OAuth going to be completed? Well, the answer is, we did in October. Thank you very much. So it's now RFC 6749 for the core specification and 6750 for the bearer token specification. So those two are put to bed. There's still a bunch of remaining work in the OAuth work group. We have dynamic client registration, which actually comes from OpenID Connect. So when we were developing OpenID Connect in the OpenID Foundation, we said to ourselves, if there are things that are generally applicable to other standards and reusable outside of OpenID, what we should do is take those pieces and contribute them to the IETF and develop them in the IETF so that they're interoperable building blocks. So as we developed OpenID Connect, we identified pieces that seem to have general applicability outside of OpenID Connect. So dynamic client registration, if in the open internet, you don't necessarily have the ability to know all of the relying parties a priori that are going to want to use a particular identity provider. Perhaps if you're an enterprise, you have a closed system for OAuth. But we needed some way of having a client / relying party dynamically introduce itself to an identity provider without necessarily forcing somebody to go through provisioning a bunch of web forms and cutting and pasting, etc. So one of the things that we had in OpenID 2 was this concept of dynamic registration. So we came up with a way of doing it for OAuth, and that's close to last call in the OAuth work group. We also have an extension to OAuth, which is token revocation. So what the OAuth core specs talk about how you get a token. There's nothing in them about how a client can say, I don't want to use this token anymore. Please throw it away. So essentially, a way for clients to say, I don't want to use the token, or some other authoritative system to say, cancel the tokens for that client via an API. That's what token revocation is about. It's in last call. There's 2 discusses on it. It's very close to being done. So before OAuth 2, we had OAuth 1, which relied on a complex signature method over the HTTP URL, which almost nobody could actually do. So there's a lot of implementation problems with OAuth 1, which is one of the things that drove us to simplify it with OAuth 2. So we're doing some work on how to do proof of possession tokens in the existing OAuth 2 spec. So some people don't want to use HTTPS for securing the protected resources for good or bad reasons. In some cases, they may have devices that are terminating the TLS and non-HTTPS traffic inside of a firewall. There may be enhanced security reasons where you want to make sure that a client that gets a token doesn't pass it on to a third party and present it. So there's a couple of different use cases which, for proof of possession tokens, what we're really in the process of doing right now is figuring out where they align, whether we actually have one or more than one solution is appropriate for the various use cases that are presented, because it's not just one problem that people are trying to solve with proof of possession, or sometimes called holder of key. The other work group that we have is JSON Web Tokens, which also comes from some work that Microsoft did with the previous the version of OAuth that they contributed to the IETF that eventually was merged into OAuth 2, and some work that I was doing with NRI at the time in Japan, which became JSON Web Tokens. So JSON Web Tokens are security tokens, not necessarily unlike SAML tokens. The main difference between JSON Web Tokens and SAML assertions is when we did SAML, we attempted to define everything and lay out a schema for exactly how everything worked, although there are still areas where even people who are part of the work group can't agree on the exact definition of issuer in or audience in SAML. So there are still some places in SAML where we have some rough edges, which maybe, but I think the problem was that we tried to define everything up front, which meant that you had to profile it down to get anything that was actually interoperable or useful. With JSON Web Tokens, we started the opposite direction with defining the very minimum set of things that you needed for a security token and allow it to be extended. So JSON Web Tokens are small, which can be extended. SAML is large, which can be profiled down. Different approaches, we'll see which one was the smarter one in the end. Undoubtedly, I'll get blamed for the failure of one of the two of them. Oh, the other thing with JSON Web Tokens, there's another standard, which I'll get to, which is called Jose. I was tired of gringo acronyms in the IETF, so I decided, since I'm Latino living in Chile, that I would have a Latin acronym. I'm originally from Canada, that's why the weird accent. So we have Jose, which is also, or JSON Web Tokens, they're used in OAuth and Mozilla Persona, if you've seen any of the talk about that. So JSON Web Tokens are being used a bunch of different places. They're already widely around. The other ongoing stuff in the OAuth workgroup that's getting close to being done is client assertions. So imagine you had an OAuth client that got a SAML assertion or a JSON Web Token from some other process and wanted to exchange that for an access token. That's what assertions does. It also gives you a way. In basic OAuth, there's a notion that clients are secured by having a password, and you use HTTP basic to authenticate the client to the token endpoint. Everyone looks really excited about that. Let's see, I'll send the password base 64 encoded over the link. That couldn't go wrong. The assertions profile also allows you to use asymmetric signatures, or even if you have a shared secret, use an HMAC for creating an assertion for authenticating the client to the token endpoint. So that bumps up the, at least reduces a number of obvious ways that a shared secret could leak out. You know, in general, people on the security side think that putting the password unencrypted on the link is a bad idea. So there's two sub-profiles of the assertion profile, a JSON Web Token, one for use with the JSON Web Tokens and one for SAML, which is typically used by people like Salesforce for taking a SAML assertion and trading it for an OAuth token for accessing APIs. So in some cases, those are already in production. They're very close to being finished. Just a few discusses left on them. Jose and our honored chair of the work group, or co-chair of the work group, is with us, so I have to be really careful about what I say. So there's four basic parts. The signature, there's JSON Web Signature, JSON Web Encryption, JSON Web Keys, which is a key format for holding bare keys or ASN1 encoded key objects, and algorithms, which we didn't put the algorithms in the actual signing and encryption. We pulled them out into a separate spec so that every time somebody comes along with a new counter mode encryption thing, we can just modify the algorithms without having to go and modify the basic specs. So they're nearing last call. We're hoping to get them done by the end of the year. There are a lot of, you can see that there's a lot of things that are kind of dependent on, yes, she's smiling, yeah. There's a lot of things that are depending upon, so JSON Web Tokens is kind of hung up on Jose because security tokens aren't very useful if you can't sign or encrypt them. And originally JWT and JWE and JWS were part of one group of specs that I was working on with Microsoft and Google and a number of other people, but due to IETF politics, JSON Web Token wound up in one work group and signing encryption wound up in another. So JSON Web Tokens can't really progress until we settle this stuff and Connect and Mozilla Persona and work that three-letter agencies in the US government are doing with JSON Web Tokens is kind of hung up on this. So this is pretty important work, and you can all take a look at the specs by clicking on them on the online presentation. The other spec that OpenID Connect also uses and contributed, so we had something called Simple Web Discovery, which got merged into a WebFinger proposal in the IETF work group. So there's two discusses left. I don't know if people know IETF speak. Discuss is when somebody important at the IETF wants a question answered and won't let it be a spec until they do. It's the short description of what a discuss is. So when you get to 0 discusses, you get the gold star, and it goes to Heather, and you eventually get an RFC number, and I think some flowers or something, whatever the process is. So WebFinger is essentially a way of dereferencing an identifier to find out stuff about that. And one of the stuff things would be where is the OpenID Connect issuer, what is the entity ID of the SAML IDP that you could talk to send this person to. So it's a useful thing. Part of it comes from social web, where people wanted to be able to, based on somebody giving them the email address, go look up a picture of them or find out where their calendar is, and sort of social webby stuff. So we support that, but Connect's interest in it is really to be able to figure out where the identity provider is. I have 2.5 minutes?
Something like this, yeah.
Over pi, what? Okay. So that's that, and we also have Skim, which we are looking at how Skim can be integrated into OpenID Connect. That's a project a little bit down the road. So Skim is now an IETF spec, system for cross-domain identity management. It used to be simple cloud identity management, but IETF has banned the word simple in anything. So they had to re-acronymize it. So there is a version of Skim 1.1, which is pre-IETF, which is in production at Salesforce and a bunch of other places. There's actually at the Cloud Identity Summit in California this summer, there's going to be an interop on Skim 1.1 and some Skim 2 stuff. One of the big differences with Skim 2 is that it's now all JSON, which is a good thing. And so that's making progress in its work group. It's not as close to being done as some of the other stuff, but there is a Skim 1.1 out there that people are. So when people say they have Skim deployed, they're generally talking about 1.1. Quite often people are a bit vague on the version numbers. Skim 2 isn't really agreed upon enough for anybody to have an actual deployment. So in the 1 minute that I have left, any questions? Yes, Ken?
John, if we interpret OpenID Connect as the new and improved versions of SAML based upon lessons learned, variations on programming language, and if, as we've discussed, this is cyclical, can you see what the replacement for OpenID Connect is, even if it's just nascent in somebody's brain? But what will be the new and improved version of OpenID Connect down the road?
I'll tell you after the standard gets to last call. I have a cycle in these things. I don't start working on the next thing until the first one essentially becomes obsolete by becoming a standard. It's sort of the way that the internet goes these days. So once it's done, it starts dying. I think that Connect has a fair amount of legs to it. It also incorporates a bunch of things from IDWSF for those of you who remember Liberty and some of the interesting work that happened there. So there's a notion of a people chooser, discovery, et cetera, that distributed claims and such that are in there. I can't necessarily predict exactly what's going to replace it at this point, but inevitably there will be, and as long as I don't my Alzheimer's doesn't get worse, then perhaps I will be involved in that. Yeah.
Hi, you didn't mention AbFab or Moonshot from the
No,
recent
because
IETF work. Do you
because I only had a limited amount of time. I couldn't cover all of the wonderful IETF topics.
So the question was how you see that fitting in with the other standards you've described here.
So there is a bunch of work in Kitten and some talk in AbFab about how we integrate OAuth into those things. Certainly, Web SSO is known to not be sufficient. Even now, Google, if you can use a version of the Kitten standard for authenticating to IMAP at Google based on an OAuth token, et cetera, that you don't have those interactive interfaces on everything. So especially for authenticating to the network before you actually have a TCP connection and a whole bunch of other things, we eventually have to, if we're going to have federated credentials ubiquitous, then we have to address all of those other things. And one of the things that we did in OpenID Connect, if you actually look at the specs, is that we separated the specification from the binding. And there's already work that we've done in Japan on alternate bindings for being able to have non-web browser devices be able to use OpenID Connect for authentication. So that is in the, we have to deal with that, but first we have to get this part of the specification done.
It is more recommended, a question regarding what you were mentioning. Recently, for example, I saw, it's a 0.0 draft on using OAuth Connect tokens for authorization of PCP connections. So you can make changes in the firewalls and the NATs, etc. And I think that opens a rather interesting field of applying OAuth tokens. Definitely.
Right. We haven't really begun to find the edges of what we'll wind up doing with OAuth tokens. There's a whole bunch of work that we have that I'm looking at with token introspection, how you actually do federated OAuth tokens, which was not something that some of the original OAuth people could even have conceived of. But right now we have, so if you have an Android phone, you're actually using federated OAuth now. What happens is that the Google Play Store intercepts OAuth authorization requests to Google, and it has a local authorization agent which has a master refresh token which actually goes and gets other JSON web tokens that are actually OpenID Connect ID tokens, which can then go back to the application and then can be used to be passed to either third parties to say, yes, you are, in fact, this application is actually authenticated as this person at Google, which is very common in the web world, like say for Foursquare or any of the sorts of phone applications that chain off of a federated identity, or even for going back to Google. So there is some work that we're just starting another work group in the OpenID Foundation on how you can have a broker agent in a device that can get tokens on behalf of other applications. So there's a lot of interest in that, especially amongst the people that are doing mobile device management, et cetera, and enterprise stuff. Yes, Ken?
So last question. Huh?
John, what happens to OIX standards if OIX doesn't survive? What's the What happens to the IPR and the standards, et cetera?
So
OIF, rather. So,
Yeah.
Right.
Two different organizations. What happens to OpenID Foundation standards if the OpenID Foundation doesn't exist? Well, the legal agreements that the various companies who contributed to the IPR would stand. We would have to find some caretaker. There's no immediate danger of the OpenID Foundation not existing. I'm unfortunately the treasurer. So it's not, all roses and caviar or anything, but we're certainly a long, long way away from any sort of precipitous cliff. So I don't have any particular fears about that. I mean, we are talking, we keep talking about having discussions with the IETF about, well, could we have a document, since the IPR isn't exactly the same, but essentially all of the OpenID Foundation standards are developed in IETF format. They're all RFC compliant. They could be published as an RFC track were that available. There could be agreements with ISOC or other people to take over the IPR should the worst happen. I don't think that that would ever happen, but yeah, certainly we would have to take care of that as, there have been foundations, which I have been part of, that have gone out of business, which you're well aware of. Information cards. Anybody want some information cards? I got a sale on.
Okay, so I guess we have to thank John for this well-informed presentation and discussion.
Thank you.
And want to turn to something completely different. The ever hot topic, identity management, is followed by a newly hot topic, software-defined networking, which already reached the Torina community, as you see on the program. And Dirk is presenting standards activities here. Dirk is heading the network management group in NEC Labs Heidelberg, and is known to the IRTF as the ICNRG co-chair, but you're not talking about ICN in the moment, are you?
Not that much, thanks. Okay, so you probably haven't been able to avoid the SDN acronym, so I'm not going to provide you much of visionary content here. This is more about to inform you what's going on SDN in different bodies at the moment. So my team and so the SDN team in our lab is involved in many of those. So this is joint work with Per Hasselmeier, so one of the SDN persons in our lab. So he's currently busy helping people who operate carrier networks or campus networks to get their applications running with OpenFlow. So this is really something that is happening at the moment. So just maybe kind of high-level explanation. So software-defined networking, I mean, you can explain it in different ways. So what's exciting to me is that you provide the interface to the network that you can use to do things in different ways with much better information about your network, your topology, your users. And the, way that this approach is implemented is normally to kind of split the control plane from the data plane. So you kind of have a standardized functionality on network elements that you can control from external controllers. And by that you can implement stuff that has been done earlier, but in a slightly complicated fashion. For example, virtualization can be kind of done in much more fine granular fashion. You can control individual flows, so multi-tenancy support becomes more powerful, easier. And people are using that to basically redesign the way that certain network functions are implemented. So for example, in mobile networks, there's a potential to kind of redesign the architecture to do mobility management in a different way. In broadband access networks, there is the potential to have a better control about, say, your BIRA systems and kind of split them up into sub-functions and so on. In order to get this, say, to the market, you need to kind of have a roadmap about things that you need to agree on. So there are kind of different layers here in that picture. So of course, network elements, network devices, they need to have some like feature set, some functionality that you can control. You need a control protocol that needs to be standardized. You may want to standardize the interface to your control software. So if you roll this out to, say, operators, they want to run their application on a, say, accepted platform, for example. And then there may be additional stuff like management protocols and so on that can still do additional to a traditional network management functionality. Then the other, say, perspective or dimension is then, say, if you have this framework, so is there a way to maybe standardize commonly used functions, so topology discovery, service discovery, and so on. So maybe another area of standardization. And so there's also some, say, work being started in this direction. So this is, say, the complicated picture of, say, all the bodies that are doing something with or around SDN. Doesn't have to say that they are really developing core SDN standards. So I think, to be honest, I think the ONF is the actual real, say, SDN standard body at the moment. It's really developing a specification for SDN. IETF is starting some work, and so most of the others, they are trying to kind of figure out what SDN would mean for their turf, for example, BBF or OIF, for example. And so in the following, I will kind of explain a bit so what's going on in these different bodies. So the Open Networking Foundation, ONF, that's the body that is standardizing OpenFlow. So the one, the most widely deployed SDN implementation today. So it's quite a big body by now. So it's like nearly 100 members, and so it has kind of the mission to transform the, say, or has transformed the initial idea of OpenFlow into something that can be built into products, so both network elements, but also control software. And so that's kind of a very active body at the moment, and so they have a board of directors that is, well, it's hosting people from those companies there, and so they're kind of steering the work together with a advisory group, and then there are a set of technical working groups and some like discussion groups that are intended to prepare potential future standardization topics. And so OpenFlow, in a nutshell, so is implementing this control data plane split in its specific way. And so the abstraction in OpenFlow is that so you can access or you can control something like flow tables on switches or network elements, manipulate flow table entries that are used to control the way that packets are handled inside those boxes. And so the way that it works is those flow table entries, they typically consist of a matching pattern that you kind of can apply to packets. You can describe some actions that would be applied to packets that actually match the pattern. And then you can also count how much packets or volume is actually being affected by a certain table entry. And so OpenFlow kind of evolved over time, of course. So it was like starting with very simple ways to match packets, and so being extended to kind of be more powerful, more expressive, and also the way that these actions are handled is kind of has been extended over time. So there is actually a concept that you can chain those flow tables inside a switch. So you can kind of direct a packet from like one table entry to another, and then have a set of actions being executed per packet, or per flow essentially. So ONF has these working groups at the moment. So architecture and framework. So one of my team members is vice chair of that one. Extensibility, that's actually maintaining the spec or developing the spec. Configuration management, there's one on optical transport. Forwarding abstraction, that's actually on how to say model switches and the hardware abstraction layer so that OpenFlow can be run efficiently. There's testing and interop, market education, and migration. So I'm not going to explain all of those, but say the top ones. So architecture and framework, they are basically trying to define the scope of the OpenFlow work in ONF. So the different elements of standardization. So there's of course the OpenFlow protocol. There's a management protocol. There may be these northbound interfaces to applications. So that's what this group is doing. That's ongoing work. They have initial drafts submitted internally. So extensibility, as I mentioned, this is the group that is actually really maintaining the OpenFlow specification, and has kind of developed quite a bit in the recent years. So recently added features, for example, IPv6 extension header handling by table entries, some form of capability negotiation, because not all switches actually can support all the features. So that's currently one of the, say, interesting questions in OpenFlow also. To what level do you actually want to have a common feature set, and to what level is it feasible or say useful to support say different capabilities of the network elements. Okay, but in general, the spec can be considered stable, and it's being implemented also in hardware. Forwarding abstraction, as I said, so I mean you can say design nice SDN concepts, but in the end, it really has to run efficiently on real-world ASICs, and this is what this group is trying to do. And so they're essentially trying to make, say, OpenFlow as efficient as possible. For example, they have the concept of say having a set of commonly used say match action tables that they want to negotiate when you set up a control connection, so that the controller basically knows what a switch can really do efficiently. And so the long-term goal is to evolve OpenFlow to a level where it can be more flexible regarding match patterns, and so maybe also looking into other domains than just Ethernet and IP. It's also ongoing work. So there's config and management that is concerned with like specifying an additional say management interface, where so OpenFlow basically controls or is the interface to say one logical OpenFlow switch in one box. And then there's an additional management interface that allows you to provide security credentials, configure ports, queues, and so on. And that's done by this group. So that is, say, what is going on in ONF, or how ONF is structured. So there's this, a separate activity that is actually not really a hardcore SDN activity. This is the ETSI work on network functions virtualization. So this actually has nothing to do with data control plane split. This is really about finding out what needs to be done to virtualize network functions, say in a sense that stuff that has typically been implemented in closed boxes like firewalls, packet inspection systems, PPP termination, and so on, to make all this run in software in say commodity high volume servers and so on as virtual machine functions. And so there is a strong pressure, say, in terms of cost reductions to get this going. And I mean, there are also like first implementations that are really promising. So this is taking place in Etsy. So it's not actually not producing standards, but it's kind of trying to lay out the standards roadmap and kind of figure out what needs to be done by different bodies. So it's, as I said, it's really not SDN, so in a strict sense, but I mean, you can imagine it makes a lot of sense to do this together with SDN. I mean, if you are able to instantiate network functions all over the place, you want to have some way to connect them dynamically, and so that's where SDN would be helpful. And so together, the idea would be to have a highly dynamic network, but also to enable innovation in a nicer way than it's possible today. So the idea would be that, say, basically any software vendor can start developing network functions, whereas today, you know, you need to have access to specialized hardware platforms normally, and say that limits a bit the innovation at times. Okay, so this is how Etsy, the Etsy NFV ISG is currently structured. I hope this is the latest version of it. So we have Diego over there, who's serving as the technical manager of the steering committee, and so they have 4 working groups. So the architecture one is kind of trying to find out the overall approach to NFV. Software architecture is like finding out so what needs to be how like the individual hypervisor platforms and virtual machine infrastructure needs to look like. There's management and orchestration, and there's reliability and availability. So one of my team members is also code sharing that one. And then they have expert groups on security and performance and portability, so like more consulting the steering committee. So this is currently also a very active group. So I've been meeting a couple of weeks ago together with the, or co-located with the ONF meeting actually. And there is also IETF work on SDN that is actually quite interesting. So I think from an IETF perspective, it's currently true to say that IETF tries to see SDN in a bit broader scope. So it's not just limited to OpenFlow. So there is an IRTF research group on SDN, SD Energy. So that is, so in my view, kind of trying to find out so what SDN kind of would mean to the evolution of internet protocols and the internet architecture. And so they're normally meeting so at every IETF meeting. There is a recently started working group called I2RS, so interface to the routing system. And that's a slightly different approach to SDN than OpenFlow. So OpenFlow is really about manipulating or controlling forwarding tables in network elements, whereas I2RS is really about accessing the RIPs say in a real-time fashion. So to kind of have a more pragmatic interface to the routing system, and by that enable a similar degree of flexibility and network control. So this has just started. I mean, they're currently discussing use cases and so trying to identify really what needs to be standardized. So it's 100% clear So whether existing interfaces or protocols would actually not be sufficient. So that work is say relatively new. And there's other work I will talk about in a second. So actually, I mean, OpenFlow may not be the only and also not the first approach to SDN. So the IETF has technologies like forces, so forwarding and control element separation, that's actually quite comparable to what OpenFlow does, but like with a different abstraction model. So it's actually say more, I would say, general model. It's quite nice. Hasn't really got traction so far, but so essentially it's also about having something like flow tables, but they call it logical functional blocks, controlling them, chaining them, and by that having dynamic control on network elements. So Alto, application layer optimization, is sometimes mentioned in SDN contexts. So that was actually, invented or started to distribute cost maps to make P2P distribution better controllable. But so can be seen as, say, one application layer source of knowledge that may be useful for SDN controllers to implement operator policy. Same for CDNI, so CDN interconnect. And the IETF is also doing NVO3, that's basically data center VPN control plane and data plane protocols. So it's maybe not a 100% SDN technology, but I think it's worth mentioning here. So this is a heads-up information, and so ITU also has kind of discovered the SDN topic now. And so they're starting basically investigating this in their, say, more study research group-like activities. But there may be some future activities on, say, more normative work. And I mean, this may be, say, interesting from some perspective. I mean, so for technology, it's kind of, say, can be helpful if everybody like ITU looks into that, kind of explains it to governments, but there's of course also the danger that so the collaboration between ITU and other bodies kind of needs to be carefully defined to make this really successful. There is actually a workshop this week in Geneva where we are telling ITT and I think government representative so what ONF is doing. So that's also happening this week. And then there's a set of bodies that are actually applying SDN to their turf. So there's the Optical Internet Forum. It's kind of starting to work on transport SDN. So it kind of goes together with so what ONF is doing in order to extend OpenFlow, for example, to other networks or other technologies. BBF, the Broadband Forum, so that's the body that is like doing recommendations on semi-standards like for broadband access and core networks. So they are looking into use cases for SDN, so things how to redesign residential gateways based on SDN technologies, how to interconnect data centers, and so on. And there's also the Metro Internet Forum that is looking into like backhaul based on SDN and so on. So there's more details on this in the appendix in my presentation if you are interested. So what I wanted to say is, so in the SDN space, there's actually not only the standards activity, but there's lots of activity going on in open source projects. So if you want to kind of use this technology or play with it, there are really tons of, say, controllers that you can use. There are many software switches that you can use. So I put up a picture of, say, the NEC controller. That's actually nice because it's an integrated emulator into a Ruby-based control system where you can kind of specify your network topology in a Ruby DSL, then develop your Ruby-based applications and say run this in a virtualized network to kind of test out your OpenFlow programs. not sure who of you is using OpenStack as a cloud management system, but so OpenStack basically is managing networking, storage, and compute, and there's also a OpenFlow plugin, so developed by NEC using Trema, that provides the network control for OpenStack using OpenFlow. And so finally, so a couple of companies have recently started an initiative called Open Daylight. It's also an open source project that is concerned about developing a more comprehensive, say, reference control, say, SDN control system that, say, provides the, say, essential control functionality, but also, say, a set of commonly used functions that you would normally use to develop applications, and then provides a, so the plan is to have a REST-based API to applications for that. And so you can see it's quite a big movement with like many vendors and software companies involved. So that just started in April. Okay, so I mean, you have seen that so there are various bodies doing something in the SDN space. So my message here is that, I mean, that the ONF is probably currently the standards body for the, say, core protocol OpenFlow. OpenFlow itself is evolving, so it's currently has evolved quite a bit from a solution for, say, campus or enterprise networks to something that is now used for carrier solutions. Related to SDN, but not identical, is the NFV work in ETSI, so which makes a lot of sense to do this together with SDN, but you don't have to. And so what we are currently doing is to see where we can apply SDN to what are actually the limitations, perhaps, and to like develop, say, better abstractions, say, more robust abstractions for really programming large-scale networks. And what we expect to see in the future is a more like operating system, like ecosystem of the commonly used functions, maybe different types of controllers that kind of bring this together in something that can really be used to provide, say, a carrier-grade SDN solution. Thanks. Any questions?
Yeah. Thanks a lot, Dirk. There is the first question in the back, and you're the second.
I'd like to connect this talk to the last one and ask, how does identity management begin to, you had users in this diagram, and those users have identities, and they want to, no doubt, use those identities to control and permissions, et cetera, for invoking SDN. How is that bridge going to be built?
Well, two things come to mind. I mean, one is you need some form of identity management for all your network elements and virtual software functions that you roll out. I think so. The development of this NFV technology basically could also be seen as a catalyst to get more of the, say, newer identity management technology being deployed. So because people can kind of really, say, use or also say other technologies for stuff that has been, say, being hardwired to boxes previously, and so then that creates, say, a demand, but also, say, many new options to use that stuff.
Andrei Rochevsky, Internet Society. You mentioned the northbound and southbound interfaces, and several organizations are working on that, but you didn't mention the east and westbound interfaces. So intercontroller, so to say, things, what's the status there? Is someone working on that?
Yes, I mean, so there is, say, one aspect, and this is basically controller implementation. So I mean, in order to control a large network, people are building distributed controllers. So many of the commercial products are actually distributed. So that's one thing, but I think what you're referring to is say, more inter-provider, right? This is the hard thing to do, and I think there is no real solution available today.
No, I understand that,
Yeah.
but the question is someone working on that solution?
So I just know that it's been discussed in ONF, right? But
We have time for one more question. So that's, I guess, you. We are running a bit late, but this is due to the price option here.
Okay, my question is partly connected to the last one. How is the inter-vendor compatibility? Is this already given, and how does the standardization work does help the interoperability?
I mean, that's one of ONF's main concerns, to say, produce something that actually leads to interoperable implementations. I mean, they are also doing like plug fests and interop tests and so on. So what I mentioned earlier, so there's a certain tendency at the moment to make OpenFlow more powerful, but that may lead to a situation where not all the switches may support all the features, and there is a certain I won't call it danger, but there's a certain challenge that needs to be addressed, and so negotiating capabilities is one approach. At the moment, I mean, because OpenFlow is developing so fast, it may be quite likely that, say, not every controller is implementing the latest spec and so on. So, and you kind of look a bit carefully so that the controller and the switch, like implementation version, really fit together. Otherwise, it's not given that they interoperate.
Okay, let's thank the speaker again.
Thanks.
And we turn to the small world phenomenon now. This is introduced by Carsten Bormann to us for the Internet of Things. Carsten is working in the Internet technologies much longer than the Internet was discovered by Microsoft. And he's in particular known in this area as the 6LoWPAN chair. So please, Carsten.
Yeah, thank you. The last two talks actually were about things where you already knew why you need them. And I probably have to start my talk with a couple of slides about what I'm trying to do here. So this is a slide you may have seen before by Ericsson, which essentially tells you in the last century people have been connecting places. And I think most NRENs are still stuck in that age. And actually, NRENs usually connect sites, which is even before that. And then the local networks do the connecting of the places. People that have then started to connect people. This headset is driving me crazy. Have started to connect people, and now we have 5 billion people using mobile phones, and that has increased the number of people on the network a lot. And the third step is that we are now starting to connect things. So this thing here doesn't have an IP address, and probably it should. And a lot of other things in this room should have an IP address, and this thing probably should have an IP address, so it can be controlled in a better way, and this outlet over there, and so on. So the idea is to get things on the internet, and we expect that to grow a lot. From places to people only was maybe factor 5, and people to things is likely to give us a lot more nodes on the internet. And we have to find out how to do that. So much of what I'm talking about is, in the end, just a scaling problem. How do we scale up to a couple more nodes, like 50 billion by 2020? So the other problem, of course, is nobody can buy 50 billion nodes unless they are really, really cheap. So we have to scale down these nodes. And they are small. I mean, we want to do everything that a device connected to the internet does approximately at the size of a penny. So we have to work a little bit on making that happen. We have to scale down cost. We have to scale down complexity, because complexity is really the thing that generates cost. And the next couple of minutes, I will talk about things like kilobytes and megahertz. And you probably have forgotten those words already. Kilobytes are interesting for us because the little coin up here, this is not just symbolizing the size, it is also symbolizing the cost. We are not down to 1 penny yet, but getting something to maybe 50 cents is a pretty important goal to actually be able to connect more things to the internet. So we have to scale things down in complexity quite a bit. We have defined a couple of different complexity classes, and one class that we actually want to support is one where we have about 10 kilobytes of data in the device and about 100 kilobytes of code. Now, those of you who have as much gray hair as I have worked on PDP-11s with about the same amount of capability. But you have to remember, we have to put a lot more stuff on a node to be a viable part of the internet today. In particular, we have to put security in there. And the whole thing has to work on a battery. So the old PDP-11s, if you remember them, did not work from batteries. These devices are then put together into networks, and usually the networks also inherit constraints from the devices. So we, apart from constrained nodes, we have constrained networks. These networks need to cope with the fact that the nodes are sleeping most of the time. So things like multicast are really difficult because, I mean, if all of you are sleeping, I can talk a lot here, but you won't hear me. So nodes need to sleep a lot. We have a pretty decent speeds at 100 kilobits per second, but then a lot of those packets don't arrive because we are sending them at very low power. So we have high loss, we have high link variability because people are not going to spend a day optimizing the link to the plant pots over there. So we typically have a pretty unstable environment. Our physical packet sizes are limited and so on. There are a number of technologies at the link layer that are getting used. I'm going to talk about a technology that is known as Zigbee most of the time, but there is also Bluetooth Smart, there is Z-Wave, DECT ultra low energy is getting defined, and so on. So we have to work in this space, and the result could be called constrained node networks. This is a very scientific term because it's really trying to capture what this is about. But it's usually called Internet of Things, or wireless embedded internet, low power lossy networks, or IP smart objects. So there are many terms for this, but the point is things are getting constrained in here. And we have a big enemy. The enemy is that we have been working on these protocols for 30 years, and they are like an old man talking all the time, and they have accumulated some fluff and so on. We need to actually work on our protocols to reduce complexity, which is probably something that most of you never have done to a protocol. You have never decreased its complexity. You only have heaped another layer on what you already have, and things get more complex. But while we are doing that, we have to make sure that we don't do another web. We don't want to create our own little work that is so disconnected from the rest of the world. Who here remembers web 10 years ago? Okay, at least some people do. So this was an attempt to reinvent something completely new for the mobile phone space that was going to be so much better that it was going to replace the web for this space. And you know how that went. So we are not going to reinvent everything. but we, on the other hand, have to do some development work to get things simple. Now, web specifically failed because Moore's law essentially made it useless. So if you spend 10 years on getting 10 times performance out of a new architecture, you might as well wait and sit on a chair and sleep, because Moore's law is going to give you 10 times performance within 5 years. So it's not, we have to be careful that we don't generate complexity by trying to reduce complexity and finally be overtaken by Moore's law. And people are actually building this stuff. So there are temperature sensors out there, like the Nest thermostat that you can attach to your wall today. This is using slightly higher energy approaches based on Wi-Fi and so on, but this is going on. And yeah, we have to be careful that what we build actually makes sense. So the most important thing for us, of course, is doing this based on IP. There has been about a decade of sensor network research where people were trying to replace IP by something better. But yeah, the problem is we need IP for integration. IP is not just the internet protocol, it's actually the protocol that we use to get things attached to our existing networks. Not only our existing networks, our existing programmers, people who know how to open a socket and get a packet out there. So that's really important to make things go. Now, you know, we do that in the IETF. And we have a couple of working groups that are working on this area. It's not an area in the IETF. The IETF has different areas like internet, routing, applications. And we have working groups in a number of these areas. So the 6LoWPAN working group is working on getting the internet part, the layer 2, layer 3 part done. ROLE is working on getting the routing done. Core is working on getting the applications done. And there are other working groups. For instance, LWIG is working on documents that support this. Our first result will be a simple draft defining terminology that is useful for this space. We have a lot of other working groups that are actually doing useful things for this. So Jose was mentioned, certainly going to be one technology that's going in there. We also are looking at things like improving DTLS for Internet of Things applications. So that at the next IETF meeting in Berlin, that's probably one of the things we will talk about. Okay, so let's talk about the network today. According to the schedule, I have about 5 minutes left. But I do have an overflow talk this evening. So all the slides I'm not managing to do, I will present at the Cisco Internet of Everything event this evening. So if you want to know more about this, go there. Let's quickly talk about the network. So there are two working groups, 6LoWPAN and the ROLE working group, which has done Ripple, working in this space. Now, this is a forward-looking activity. And we're talking about 50 billion nodes. So you know that IPv4 is gone. So all this is completely focused on IPv6. We are not really interested. There are going to be some special NATs making this work somehow with IPv4 infrastructure, but that's really not something that we care about. So when we finally submitted our standard to the ISG, one comment was, has anybody looked at how this works with IPv4? And we kind of blushed and said, well, we can do that now. So when we take our constrained networks like the ZigBee technology, we are not using the ZigBee standard, which is a silo standard, not internet connected. When we're using the ZigBee radio technology, that gives us 120 byte packets, not quite enough to run IPv6 over, but certainly something we can build on. And we have different frequencies. We have 2.4 gigahertz for the world. And if you actually have to penetrate walls a little better, there is a 900 megahertz version, but that requires regional variance because 900 megahertz is not the same in the different regions. So that's something that we can work on. That standard has been around for about a decade now. There are several hundred chips you can buy that can be used in these systems. So the next question was, how do we actually build an IPv6 link out of this? And we solved that problem in 2007. So there is an IP over Ethernet standard and an IP over ATM standard. There is an IP over 802.15.4 standard. That's the basic 6LoWPAN standard. And that defines the encapsulation and defines how to do the fragmentation. There are some parts that we didn't get right in 2007, which are no longer relevant. Oh, by the way, 802.15.4 has a really complicated MAC layer. And one of the things that we did when we defined 4944 on top of that was mostly discard most of those MAC layer concepts. So we are using a very simple subset of the 802.15.4 MAC layer to make this happen. Okay, that was one thing. Again, we didn't quite get the header compression right. Header compression is important with IPv6 because an IPv6 header is 40 bytes. And if we only have 127 in total, we really don't want to spend a third of that for IPv6. We are already spending almost a third of that for security, so it's getting tight. And we don't want to give up the security. So we had to work on header compression, and we actually came up with a slightly better version of header compression in 2011. So this is another draft known as 6LoWPAN HC that turned into an RFC 2011. So we now can send those IP headers, including UDP, in maybe 7 bytes. So that's quite acceptable for our world. But the third thing, the real pig in making IPv6 run over a zoo of sleeping devices is neighbor discovery, because neighbor discovery really is based on multicast and on the idea that every node is reachable at every time. So for instance, a node can defend its address. If somebody else tries to steal its address, it can go ahead and say, no, I have that. Of course, if it's sleeping right now, it's not going to defend it and will lose it. So we are not doing the multicast version, but we have come up with a link model that allows us to build something that looks like a IPv6 subnet, but actually contains routers. That's the route over mechanism. And we have redefined neighbor discovery a little bit to make it work almost completely based on unicast. So this is how things look like in a 6LoWPAN. We might have 1 or more edge routers or 6 LBRs. And we have routers in there, of course, because that might be in one end of your apartment, and the plant pot you want to talk to is in the other end, and you need to have a router in the middle to make them talk to each other. And the point is, you don't really want to change the address of this guy when it chooses a different router. So we had to come up with a different addressing infrastructure. And we changed we changed neighbor discovery a little bit by making address registration explicit, so that there is now a way a host can say, I want to use this address, hello router, I'm going to use you as a router, and I'm going to use this address. And we have various options that distribute information within the 6LoWPAN, so all the nodes actually know what's going on, who's their edge router, and what is the header compression context that is going to be used in this network. So what happens is that when a host wakes up, it's going to do a local multicast for a router, find a router, and then register with that router, which possibly causes additional messages to the edge router, and then it is in the network. After that, it never has to respond to a multicast or something like that any longer. So actually, this works so well that the Ethernet people are now thinking about putting this part of neighbor discovery back into the Ethernet neighbor discovery. This is called efficient ND. So the simplifications that we are doing actually seem to flow back into the general internet. So the main reason to do this is to save energy. It also solves a particularly nasty security problem of neighbor discovery, because you no longer have to ask for where a particular host is, and so an attacker cannot enumerate all the 2 to the power of 64 hosts in the network. Okay, so this is 6LoWPAN, and this is pretty much done. 6LoWPAN is defined as this RFC minus the obsolete stuff in there, plus this RFC, plus this RFC. And if you're interested in this stuff, we're going to have an interop at the Berlin IETF. Etsy is running that for us, so it's kind of an arrived technology. There have been other interrupts, lots of interrupts before, done by pay-for organizations like Ipso. This is the first free interop that is being formally organized. If you know people in your organizations working on constrained networks, talk to them about this interop event. Okay, so this was the network layer. Again, there are other radios out there. Those radios are defining their version of 6LoWPAN. So Bluetooth Smart or Bluetooth Low Energy, as it's called, that has a draft that is essentially cooked, and it's just waiting for the channel assignment in the Bluetooth 6. So it has gone beyond the discusses that John mentioned, and it just has a final discuss, where's your channel assignment, and as soon as we can answer that question, it's going to be an RFC. One of the designers of Z-Wave has put in a draft on how to do this for Z-Wave. So this is an interesting 900 megahertz radio that is very popular in Europe. That has a pretty much done standard, but it's not yet through the institutions, and the DECT people are working on this. So the 6LoWPAN working group actually is shutting down because it has done its work, but there may be a new working group coming up that will bundle the standardization in this place. So if you hear something about 6LoWPAN is shutting down, that is just a form of reorganization within the IETF. We don't like to have long-running working groups, except for some. I mentioned Ripple, the role working group. That has delivered an RFC in 2012, which essentially defines 2 subrouting protocols. Both are based on directed acyclic graphs, which are essentially trees with redundant paths. And there is one where we expect the routers in the middle to be intelligent, and one where we expect them to be dumb. And of course, the industry has implemented this version, and the academic community has implemented this version, and we are working on getting some interoperability here. Okay, but this is essentially also a done protocol. There have been a number of interrupts in this space too, and if your situation goes beyond a simple star with one central node and a couple of nodes around that, then Ripple can be used as your routing protocol. Okay, I have a couple of minutes left, so I'm not going to tell all the things I wanted to tell about applications, but I want you to add one word to your vocabulary, which is the constrained application protocol. when we started this work, people were wondering, well, what are we going to use to access those nodes? What is going to be our application protocol? And of course, people had been using HTTP for that for a long time. And so the question was, can we just go ahead and compress HTTP? Compressing HTTP saves some bytes, but it retains all the existing complexity of the protocol and adds another layer of complexity for doing the compression, because doing this in a good way adds a lot of complexity and also a lot of severe requirements. And then you still have to do TCP below that. And even then, compression is not going to give you a very good result. So we decided, let's do something else and do a UDP-based protocol that is almost, but not entirely, unlike HTTP. So some of you will have caught the Douglas Adams reference here. So it's doing the same things HTTP does, but it's doing those in a much simpler way. So this is based on HTTP's REST model. We have things like get, put, post, delete, but we don't have the baggage of 20 years. We actually can stand on the shoulders of the HTTP people who already have learned which parts work and which parts don't work very well. So we are doing this based on UDP or DTLS for the security part, and I'll talk more about that this afternoon. We have something like a 4-byte header, and the header fields, you know, from HTTP that are taking 500 or 700 bytes. We encode that in a pretty compact but very simple encoding, so you can implement all this in a couple of kilobytes. And we also have added a notification architecture. So a sensor can simply send a couple more responses when it got an initial request, what's your temperature? It then can go on and send a notification every minute or whenever the temperature changes. So for the programmer, this really looks like HTTP. There isn't really that much that changes, except maybe that the nodes are self-describing. So we have a data format, so a node can say what's in there. And yeah, for the implementer, of course, you cannot use your existing HTTP library. You have to write a new one, but this stuff is simple. So this is pretty much the protocol on a slide. So we have confirmable requests and acknowledgements, and we have a byte that has either a method or a response. We have a message ID, so we can match requests and responses, and we have options to keep the parameters. Okay, I want to stop at this point. Maybe we have time for a couple questions, and otherwise, again, I redirect you to the Cisco event this evening.
Yeah, thanks, Carsten. Questions? Comments? Counter speeches?
No counter speech, but is there no role for TCP in CoAP?
There might be. So there are people who are building backend infrastructures, which may have to talk to millions of servers. And like in an HTTP server farm, you probably need something between the front-end load balancers and the back-end application servers. So we are looking at ways to run CoAP over TCP. And there may be other places where that makes sense. But the assumption is the temperature sensor is not going to use TCP, but the higher performance elements of the infrastructure will.
No more questions? Okay.
You mentioned the HomeNet activity in the IETF. What do you see as the main challenges in integrating these types of technologies into home networks where you're going to have very different types of media, etc., and other types of applications?
Well, the main challenge is making it work. Yeah, you know what those challenges are. We want to build IPv6 networks that contain a Wi-Fi part, a coax part, a fiber to the provider part, a couple of sensor networks, and so on. We want to make all that plug and play. And that's really the challenge.
I was just very interested in some of a couple of the slides you had there, suggesting some of the things you essentially learnt from designing 6LoWPAN could be applied back to regular Ethernet networks. Do you see that? I mean, was that a bit of a glib comment, or do you see that actually happening? I mean, what's your thought on that?
There is a draft, and that is
okay. There is a draft, but do you see it going somewhere?
There is a lot of interest by those people who want to run IP in data centers, and they really want to get rid of all this multicast overhead. So it makes something that actually makes running IP in data centers easier. In a home network, it's mostly useful to handle sleeping nodes. So it may be something that you want to do in home network, but it might take a long time till all Wi-Fi devices learn how to speak this protocol. Much easier to roll it out in a data center.
Okay, so there are no more questions. I guess we are all ready for the coffee. Let's thank all four speakers, sorry.